Maybe Europa doesn't have plumes after all. A new way to detect dark matter. Maybe exo-venuses are more common than exo-earths. A private flight around the moon and Mars. And in Space Bites Plus, how the solar cycle influences space junk. All this and more in this week's Space Bites. Once again, another recording from the road, another teeny tiny hotel in Japan. I promise you, I've tried to set this camera up however I can, and then outside it's extremely loud. So this is what we get this week. So you know how there are plumes of water ice blasting out of Saturn's moon Enceladus. This is exciting because you've got this direct access to the water on Enceladus, and it's being just thrown out into space for us to collect. Astronomers have also seen hints that something similar is happening on Triton, which is Neptune's largest moon. And in 2014, astronomers announced that they had detected evidence of plumes on Europa, which is one of Jupiter's moons. And this is incredible because Europa is this world that several spacecraft are flying to right now. It has really intriguing evidence that there is this thick ice shell surrounding this ocean of liquid water, more ocean than we have on the Earth. And if these hydrothermal vents are interacting with the water, perhaps these are injecting energy and chemicals into the water, and then this could be the basis of an ecosystem on Europa. And then if this water is being sprayed out into space, then we can analyze it and search for the kinds of organic molecules that could indicate that there is life in the biosphere under the surface of Europa. And that's why that announcement was so exciting back in 2014. The discovery was made using the Hubble Space Telescope. Astronomers looked at the ultraviolet signature of hydrogen in the vicinity around Europa, and they found what they thought were two plumes that were about 200 kilometers high, blasting out of the surface of Europa. Well, those researchers have gone back and re-evaluated their data. And one of the big questions they had was, did we get the location of Europa exactly right? That if your observations are off by a pixel or two, then you're not looking at Europa, you're looking at the atmosphere of the Earth, because of course the Hubble Space Telescope is orbiting around the Earth. And so the astronomers did this process. They looked at their old data and found that it probably was caused by interference of the Earth, the hydrogen in the Earth's atmosphere, and not hydrogen around Europa. And so they have withdrawn their discovery, and so now it seems less likely that there are plumes on Europa. But of course, we've got two missions going to Europa right now. We've got the Europa Clipper from NASA, and we've got the European Space Agency's JUICE mission. And this will be well outside the influence of the Earth's atmosphere. And so this will tell us if there are indeed plumes at Europa. And we've got a story about this from Evan Goff. Now, our observations tell us that dark matter accounts for most of the mass in the universe. But because it doesn't interact with regular matter, or even itself, in any way except for gravity, it's been really difficult to observe. But once we observe the universe in terms of gravity, watching the rotations of galaxies, watching the movement of stars in galaxies, seeing the gravitational lensing of mass, we can detect the presence of dark matter out there. And now astronomers have proposed another way to detect the presence of dark matter, and that is looking for a signal in gravitational waves. The idea is that there's one flavor of dark matter that consists of ultralight particles, something that is much lighter than, say, even the electron. And yet, as black holes are rotating, they should collect dark matter particles in their vicinity and then kind of churn them up. And the analogy the researchers used is that you're sort of churning milk into butter. And then, as two black holes are in the process of merging, say one black hole is going to pass through this cloud of compressed dark matter particles around the other one. And that should slightly vary the signal of the gravitational waves that are received on the gravitational wave detectors on Earth, on LIGO, Virgo, Kagra. And so if researchers tune their observations to look for that additional signal of that moment where the black hole is passing through this butter of dark matter particles, then that should be detectable with our gravitational wave observatories. And the timing is really good. The LIGO detector is offline right now while they're making some upgrades. They're going to bring it back online to assist with Vera Rubin observations. And then they're going to take it back offline and they're going to make even more upgrades. So we might get to this point where these are the kinds of observations that these big gravitational wave observatories can detect. We've got a story about this from Mark Thompson. So if you've ever walked on sand, you know how much of a pain it is. Like whenever you see these people, they go running on the sand like it's some kind of carefree experience. It is nothing like that. Your feet sink into the sand. It requires a lot more energy. It's exhausting to walk on the sand. But there's a kind of lizard called a sandfish skink, and it's able to move through sand like it's swimming instead of walking. I sort of think about sandworms on Dune, but a tiny little lizard. But now, German engineers have developed a type of rover wheel that should mimic the process of how this sandfish skink moves through sand. And so if you look at the wheels, they're warped. And so as they turn, they sort of push back and forth and create this sinusoidal motion through the sand, which is similar to the kind of motion that the sandfish skink uses. And they were able to measure the amount of energy it took for their rover to move through the sand. And it was less than just straight up wheels that can sink in and have a harder time moving through the sand. There is sand on Mars, but there's other kinds of terrain as well. And so the researchers are trying to come up with some kind of hybrid approach so that the wheels can turn both going through sand, but then be able to work on other rocky terrain, harder terrain, and so on. But it's very cool when you've got this biomimicry, when researchers see some solution that nature has come up with for moving through some kind of terrain and then have adapted this for a rover. We've got a story about this from Evan Goff. Astronomers have yet to find another Earth-sized world orbiting around a sun-like star within that star's habitable zone. I mean, we know of over 6,000 exoplanets, and yet we haven't found that other Earth. But we also haven't found another Venus, although they've got to be out there, right? And in fact, we saw a lot of excitement in theorizing that one of the first planets in the TRAPPIST-1 system was going to be one of these exo-Venuses. But right now, the observations say they're probably airless worlds close up to the star. Maybe there's an exo-Venus later on, but so far, we don't know. Well, a new paper's come out, and the researchers say that exo-Venuses are actually probably more likely than exo-Earths. So when we look at the planet Venus, we sort of think about the history of this planet. And a lot of people say, well, Venus started out very similar to the Earth. It had oceans of water, and then at some point it turned bad. But the researchers said, well, maybe it was always bad. Maybe you had this planet with magma oceans, and then it just translated into this stagnant lid, this thick atmosphere of carbon dioxide, and then that was just locked in for the rest of its life. And so if that's the case, well, that's actually a much simpler process to go from magma ocean to stagnant lid, build up the atmosphere, then to go this process where you're able to accumulate and condense the water to make oceans. And so the researchers propose that in fact we should find a lot more exo-Venuses than we find exo-Earths. We've got a story about this from Bruce Dormany. In 2025, the Chinese-born cryptocurrency millionaire Chun Wang led the Fram-2 private spaceflight. This was an orbital mission around the Earth on a SpaceX Dragon capsule. He got the bug, and now he wants to go back to space. And he has put his name in to be able to do a flyby of the moon sometime in a SpaceX Starship. And of course, I'm recording this on a day when the SpaceX Starship was supposed to fly. Now it's been delayed, but in theory, we should see new launches of the new design of SpaceX Starship. And we saw the completion of the Artemis 2 mission, which carried 4 astronauts around the moon. So this is clearly, something that should now be replicated with a private spaceflight. But Wang wants to go one step farther, which is that he wants to go on a flyby around Mars. And this is an idea that has been percolating for a while. I've reported on flyby missions like back in the 60s, where people were thinking about flybys of Venus and flybys of Mars. So you're looking at hundreds of days in space where you fly all the way around Mars. It takes like over 500 days to complete a flyby of Mars. We saw a proposal back in 2013 from Dennis Tito, who was the first private astronaut space tourist, and he proposed a 501-day flyby around Mars, where he and his wife would fly around the red planet. And of course, we saw a proposal in 2018 where the Japanese billionaire Yasuko Misawa wanted to take a crew of artists and filmmakers on a flyby around the moon, and then he pulled the funding and canceled the mission in 2024. So a lot of people are proposing this idea, and this is all just going to rest on whether or not the SpaceX Starship is going to be up for the job. And of course, also, we need to have all of the space hardware that would be required to keep a crew of astronauts alive for hundreds and hundreds of days on this deep space mission around Mars. But if we see successful launches of the SpaceX Starship, if SpaceX is able to demonstrate space-based refueling, if they actually ever send a spacecraft to Mars, then maybe we'll see an actual human mission around Mars. We've got a story about this from Alan Boyle. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner last week was a Kuiper-Belt object found with an atmosphere. So thank you everybody who voted. Now, when you're watching this video, the new vote will be in the post tab on our channel. Of course, if you want to see these polls, subscribe to the channel and then go into the post tab, vote on a bunch of past polls, and this will train the algorithm that this is the kind of thing that you want to be able to participate in. There's a classic problem in mathematics called the traveling salesman. And this is where you try to connect together a bunch of cities on a map so that you can visit them all in the shortest amount of time or the shortest distance. But you can imagine you can take this to the next level where you're trying to conduct a spaceflight mission across many asteroids. Of course, once you go to space, you have to consider you are traveling in 3 dimensions. Where you're coming from, where you're going to, are moving. There's gravitational influence, gravitational assist. It is a very, very complicated problem and requires an enormous amount of computational resources to be able to make these kinds of calculations. And yet, future missions are hoping to do surveys of dozens of objects, or maybe asteroid mining to survey what are potential places to harvest resources from. Now researchers have come up with a much more efficient routing algorithm for space missions. And they were able to shatter the computational time required for computing a 15 to 30 asteroid destination mission by collapsing some of the legs of the journey and simplifying things in ways that didn't actually change the complexity of the various journeys that they would take. And speaking of asteroid mining, there's this company called Astroforge that has built this Odin satellite, and they're planning to survey an asteroid called 2022 OB5. And this was considered a prime place to conduct asteroid mining. You've got this asteroid that has a large amount of metal, it has a very low delta V trajectory to get to it. In other words, you don't need to use a lot of propellant to be able to get to this asteroid. So this was the ideal target. But new evidence shows that this asteroid is spinning very rapidly. In fact, it's spinning about 100 times faster than the surface gravity would hold on to objects. It takes about 1.5 minutes to complete one rotation. And so if you were able to actually move in sync with this asteroid and then you tried to land on the surface, the spin would throw you off again. And so this is a new challenge. These ideal asteroid mining targets, the ones that are made out of metal, are also the ones that can hold themselves together while they're spinning very rapidly. You probably remember some research that came out of Vera Rubin where they had identified some of the most quick spinning asteroids ever seen. Asteroids that are spinning so fast they should have torn themselves apart if they were a rubble pile. And so instead, they're solid rocks or chunks of metal. So these are ideal targets, and yet it looks like they might be really difficult to try and do any asteroid mining from. Got to slow down their rotation before you can actually work with them. Both of the stories I talked about in this segment are on Universe Today, written by Andy Thomaswick. NASA's Psyche mission just completed a gravitational slingshot around the planet Mars. Now, normally when spacecraft complete these, they're looking for a gravitational assist, a boost in their speed. But in this case, Psyche was looking to change its trajectory to make it easier for it to get to the asteroid 16 Psyche. But of course, whenever a spacecraft completes a flyby of a world, this is the ideal opportunity to take a bunch of pictures, test out all of the science instruments on the mission. They were able to capture images of the southern polar cap and the Valles Marineris region, as well as images of the Syrtis Major region with these really cool wind-blown structures where dust is coming off of all of these craters. And the Huygens crater, which is the 5th largest crater on Mars. It's about 467 kilometers across. And one of the really exciting parts about this is that they were able to test this laser communication system that I have been talking a lot about. It is able to communicate back to Earth at broadband speeds. It's estimated that when this is fully operational, they should be able to communicate data back home at about 100 times the throughput of what they can get through radio transmissions. And with this successful test of the Psyche mission, it's on to asteroid Psyche, which it should reach in just a couple of years. And then we are going to see close-up images of this metal asteroid that might even have metal volcanoes. Got a story about this from Evan Goff. I hope you're enjoying this week's episode of Space Bites. Of course, you probably had to watch an ad at the beginning of this episode. And so if you want a place where you can watch our episodes ad-free, you should definitely check them out over on Patreon. And to encourage you to do that, we're going to put one additional story in this week's episode. And this week's bonus story is how sunspot activity can unpredictably speed up the re-entry of space junk. So I'm going to put a link in the show notes so you can check out that version over on Patreon. And of course, this is just a fraction of all of the stories that we're covering on Universe Today. Typically between 30 and 40, although that number keeps getting higher as I bring on more writers. But anyway, if it's too many stories for you to stay on top of, you need my weekly email newsletter, which I write by hand every week. There's no ads, completely free. I send it out every Friday. You can go to universetoday.com/newsletter to sign up. All right, I'm going to talk about what happens when science changes its mind. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Brian Bodie, Caradon, Chuck Hawkins, Commander Bailock, Dark Finga, David Gilton, and David Matz, Enthralla Reading and Math for Toddlers, Eric Lindstrom, Evan.pro, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Sutz, Michael Purcell, Nordspace, OneServerAnimals.org. Please follow my nephew at Vbrick6994, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Fallon-Munley, Team 49, Telescopes Canada, Vlad Chiplin, Wolfgang Klutz, and Zeldaborg Galactic Defender, who support us at the Master of the Universe level, and all our patrons. All your support means universe to us. So this week's story about Europa is a classic science story that we hear, which is where researchers make an announcement about some scientific finding or some result of some study, and then a couple of years later, they announce the opposite thing. Now, in some cases, it is different teams. So one team announces some discovery, and then another team announces that that thing that first team discovered is probably not true. But this is an amazing example where the team made the announcement in 2014 and then a new idea came up. They reevaluated the data because they wanted to be sure, and then they retracted their discovery. This is how science works. Science is always moving. Science is always about building up your results from the evidence that you see, that you're trying to always maneuver your way towards truth. And if the truth is uncomfortable, if the truth turns out to be something that is the opposite of what you originally found, well, you change your mind. That you want to have that flexible, open ability to change your mind, to be skeptical of your own work, of other people's work, and to always try and reach a scientific consensus where every possible avenue has been investigated. And so, whenever you hear coffee is good for you. Now coffee is bad for you. Now, oh wait, coffee is good for you. You shouldn't be frustrated by this. You should be glad. You should be glad that scientists are continuing to evaluate their work and to change their mind and to publicly retract what they said in the past when new information comes along. And whenever they have the best possible information at the time, they are going to do this. And you don't see this in other fields. When people make mistakes, when people realize that the path they were on was incorrect, they don't publicly announce they've changed their mind. They enter a state of cognitive dissonance. They try to firmly continue to hang on to their previous beliefs, even though they turned out to be wrong. And so science is really good at this. And when you watch this process unfold in science, it just feels great. All right, we'll see you next week.